My name is Jeff Bennett, and in this presentation I'll be talking about photonic integration and the digital optical network. Before the advent of the integrated circuit in the late 1950s, we were obliged to build electronic systems such as computers using the kind of discrete components you can see here on the left. These components remain expensive even today because the cost of each component can't fall below the cost of packaging it. Components are also quite bulky because the size of the component can't be less than the size of its package. The computers that were produced using these components were so expensive that the CEO of the world's largest computer company at the time forecast a demand for only 5 such systems worldwide. These computers took up entire rooms, consumed vast amounts of power, and needed a small army of technicians to keep them working because they continually broke down. Fast forward to today, and of course we're all familiar with the results of the integrated circuit revolution. Computing power has become pervasive. In fact, a typical smartphone today has far more computing power than all of NASA's computers at the time of the moon landings. Today, we expect computing power to be small, cheap, extremely reliable, and able to run on batteries for hours and hours. If we now turn to the optical transmission world, this is about where the electronic world was in the late 60s. We see an entire generation of optical transmission systems that were designed in the 1990s using discrete optical components. And not surprisingly, these systems are costly, bulky, power-hungry, and failure-prone. The DWDM revolution of the 90s meant massive additional bandwidth became available to carriers. But as I've explained, the technology used to build these networks is constructed using discrete optical components. With dozens of wavelengths being transmitted down a single fiber, hundreds of optical components are needed at every node. At Infinera, we've invested in the Photonic Integrated Circuit, or PIC, a technology that allows us to literally shrink all of these expensive optical components onto 2 chips, one for transmit and one for receive. PIC technology is having the same impact on optical networks that integrated electronic circuits had in the consumer electronics world. Costs are falling, functionality is increasing, and system reliability is improving dramatically. For example, Infinera customers are now reporting around 15 million in-service hours for our PICs without a single failure. PICs also enable a return to digital optical networking, where information is carried through the network in digital, not analog form. Digital optical networking lowers both the CapEx and OpEx of your DWDM network and allows you to respond more easily to customer demand. The Infinera DTN is the world's first PIC-based optical networking system. Using the power of photonic integration, we're able to scale 10 times faster than conventional DWDM equipment. An Infinera network requires around 75% fewer man-hours to plan, engineer, and deploy. We support between 2 times and 4 times the number of network ports per rack inch. We achieve higher reliability thanks to the massively reduced component count and around 97% fewer fiber couplings. And the power of the digital optical network allows you to configure your systems for forecast tolerance, to the capacity that's needed right now, to the right service mix and traffic matrix for your business. I'd like to tell you more, but I've run out of time. If you browse our website, you'll find a range of resources about Infinera, photonic integration,